Hello everyone, in this video we will see how to insert a node at the end of the list. In the previous video we have seen how to insert a node at the starting of the list, and in this video we will see how to insert a node at the end of the list. Let's say this is the list, and if I want to insert a value, let's say 25 at the end of the list, then after the insertion the list should appear to be something like this. So next.12 should be pointing to the node which hold the value 25 that we are inserting. Incidentally, this list is sorted, but it may or may not be sorted. For example, when you are implementing queue using a linked list, then you insert at the end of the list and you delete from the head of the list. So you are always inserting at the end of the list. Now there are multiple ways in which we can implement this insertion at the end of the list. If your use case is that you are repeatedly inserting at the end of the list, like in the case of queue. So if you are implementing a queue using a linked list, then insertion will always happen at the end of the list. So if we are always inserting at the end of the list, then it makes sense to have a pointer which is pointing to the last node of the list. So we will have a tail pointer. The tail pointer is initially pointing at 12. After we insert 25, now the tail pointer should start pointing to 25 because 25 is the last node of the list. So we will have a head pointer, we will have a tail pointer. In this case, the time complexity of inserting the node at the end of the list will be constant. But if we do not have a tail pointer, if we do not maintain a tail pointer, and this is a one-off case that once we are just that we want to insert at the end of the list, and we only have a head pointer of the list, then there is no way but to traverse till the end of the list. So we will have to traverse till the end of the list, and when we reach the last node, then we will have to make adjustments to insert the new value at the end of the list. In all the cases, we are inserting a new node, so we are creating a new node. So the first thing that we have to do is we have to create a node. I am assuming a node class like in the previous example. So this is the node class, and in the node class we will have one integer data, next pointer, and for the sake of simplicity we have written a constructor in the class so that we can easily create node using new operator. So the first thing that we will do is that we will have an object of node class. Let's say the name of the object is temp, and then we'll say temp is equal to new node with the value that we want to insert. In this case the value is 25, so we'll say new node 25. Now after this, so let's have the linked list. Let's say initially this is the linked list. So the first thing that we are doing is we are saying node temp is equal to new node with the value 25. Then after doing this, a new node will be created. The data of this node will be 25. The next will be null, and temp is a pointer that is pointing to this node. The data and next are adjusted in the constructor of the node class. In the node class, we accept a value, and data is equal to value and next is equal to null. So after the execution of this statement, a new node is getting created and temp is pointing to that node. Now we have to somehow move this head pointer to the last of the node. So I'm just typing here. So first thing is node temp is equal to new node with value 25, and I'm just rubbing this handwritten note. Alright, so first thing that we have done is this. Now we want to move the head pointer. So what we can do is that we can have another variable that holds the head so that the original head doesn't change. So node h is equal to head while h dot next is not equal to null. We say that h is equal to h dot next. In this case, first we will have an h here, then next of h is not null, so h will come here. Next of 7 is also not null, so h comes here. Next of 10 is also not null, so h comes here, and next of 12 is null, so h will stay here, and we move out of the while loop. Now when this while loop gets executed, this is how the linked list and the pointers look like. Now what we want to do is that we want to set the next of h to temp. So this is pretty simple. We'll say that h dot next is equal to temp. Now next of head is temp, which means that it is no more null, and that's it. So essentially this is the code of inserting at the end. Now if you look at it from implementation point of view, there are two types of implementations. One is if we have a class by the name linked list. So if we have a class by the name linked list, then head is the property of that class that we probably do not want to expose to the outside world. So we will have something like this. We'll have a class, let's call this class my linked list, and inside this class we will have everything that is needed for this class. So we'll have a node class inside this, then we'll have a node pointer, that is head. I'm using the Java syntax, so in Java syntax node pointer means node reference, so node, right? Then we'll have the public APIs of this class. So one of the APIs is the constructor of the class, and another API is public insert at end. So insert at end receives an integer value, and this should not return anything because head is internal to the linked list. So if head is internal to the linked list, we should readjust the head. Okay? So it should not return anything, and it should be a void. Now inside this we will have a code like this. So whatever we have written will go inside this function, and then we have to check our code for boundary conditions. Our code is not handling a boundary condition properly, and that boundary condition is what if head is null? What if our linked list is null? So if the linked list is null, it means that we do not have any node in the list. If we do not have any node in the list, then head is null. When head is null, and then when you try to access next of head the way we are doing it here, then it will just crash. So this code will crash when we try to insert the first node, and we should handle that programmatically. So the way we can handle that is that we can put a special condition for the first node. So if head is null, anyway we will be allocating this new node. So if head is null, then what we should do is that we should just say that head is equal to temp. So if head is null, then head will become temp, then the new node that we are inserting will become the head node. Otherwise we will go all the way up to the end of the list, and then we will insert the new node at the end of the list. So in this case, the time complexity of this insert at head function will be on the order of n. We are taking this time in not inserting, but in traversing up to the end of the list, because we are inserting at the end, so we have to go all the way up to the end of the list. So that's why we are taking so much of time. If the same thing is getting implemented in C language, or if we do not have this object oriented class my linked list, so if we do not have this class my linked list, then probably what we will have is that we will have a head pointer that is global, right? So we will have node head that is global. If node head is a global function, or like in C language what happens is that instead of having a class by the name my linked list, you will probably have a file by the name mylinkedlist.h and mylinkedlist.c. mylinkedlist.h will have the headers or the APIs of linked list class, and the C will have the implementation, and this head will be a global variable in that class, in that file. So if this is the case, that the main function can access the head, the same head which we are using in the function, then probably our return type will be different. So our return type will be the new head, and we will say insert at head integer value. So here we are inserting the value at the head, and we are returning the new head of the list. If we are inserting the first node, then the head will change and it will be a completely new head. If the node previously had some values, then the head will remain the same, so we will just return the same head, so that the calling function can take the actions accordingly. In this case also, the time complexity will be on the order of n, because we will have to traverse up to the end of the list. If we maintain a tail pointer, which is pointing to the last node of the list, then essentially what we have to do is we will just have to do tail.next is equal to temp, and then tail is equal to temp. So essentially this is what we have to do, in addition to handling the boundary condition when both head and tail are null. So if both head and tail are null, which means that we are inserting the first value in the queue, then probably we will have to set the head also. But otherwise, if head is already set, if the linked list or the queue has some values and we want to insert at the tail of the queue, which we do in most of the cases for queue data structure, then this is what we do. So inserting at the tail of the queue will be a constant time operation. because we don't have to traverse up to the end of the list. Alright, I think we cover all the cases. So if you want to unit test your code, probably you need to test for whether the code is working when my linked list is null, whether the code is working when my linked list has one element, and whether your code is working if your linked list has any x number of nodes where x is greater than 1. Alright, so I think this is it for this video. For more such videos, please keep visiting this channel. Thank you.